As local area networks grew and developed, it became increasingly necessary to be able to connect their resources together over long distances. We initially met these challenges via the phone company network. The public switch telephone network PSTN, and the first successful network able to establish voice communications over disparate locations was born. Few of us remember back to a world without phone service, which made PSTN an obvious solution. It was already a fully operational circuit switching network, enabling every phone call to establish a unique circuit from one endpoint phone to another through a path of switches. So instead of reinventing the wheel to design LANs, early network planners used packet switching as their communications delivery method. As you can imagine, wiring these packet switched networks to enable communication over vast locales wasn't exactly something we could get done quickly. So even wide area networks WANs used the existing phone company network back in the day, but all solutions aren't created equally. And this one just wasn't so great due to its hefty price tag, and because it imposed some ugly data transfer limits on the networks it served. So that's the history for you, but know that it's not a thing of the past yet. Today's WANs are communication networks that cover broad geographic areas, and they still frequently use phone companies service providers in concert with their circuit switching networks to connect LANs together. Competition can be a great motivator, and with the internet entering the scene, giving us an alternative way to connect LANs, we benefit tremendously from the resulting reduction in the cost of our connectivity. These new connection options, along with their related protocols and technologies, can greatly reduce the cost of a WAN's infrastructure, and lowered transport costs are a huge relief for network administrators and designers alike. An important fact to lock into memory is that WAN protocols and technologies all occupy at least two of the OSI models, lower three layers: the physical layer, the data link layer, and sometimes the network layer as well. Coming up, we'll examine the various types of connections, technologies, topologies, and the devices used with WANs, as well as how to create WAN connections using different transmission such as air, wireless, space, satellite, both copper and glass fiber for wired connections. But before we go there, you will need to know some basic WAN terms. Defining WAN terms. Before you run out and order a WAN service type from a provider, you really need to understand the following terms that service providers typically use. Customer premises equipment, CPE. Customer premises equipment is equipment that's owned by the service provider but located on the subscriber's your property, CSU, DSU. Channel service unit, data service unit is a layer 1 device that connects the serial ports on your router to the provider's network and connects directly to the demarcation point, demarc, or location. These devices can be external as shown in figure 16.1, or they can be internal cards on the router. The CSU DSU provides clocking of the line to the CPE, in this case your router, and provides other important options like voltage regulation. Smart jack. As you can see, there's a smart jack or network interface unit, NIU, installed between the demarcation location and the CSU DSU at the customer premises equipment, CPE, location. But why is it there and what does it do? For starters, a smart jack can provide signal conversion by converting codes and protocols, e.g. framing types, into something the customer equipment requires, plus the NIU can buffer and or regenerate the signal to compensate for signal degradation from line transmission. This is very similar to what a repeater does, but there's more. Smart jacks also typically provide diagnostic capabilities to the ISP, something a demarcation location just can't. A very common and vital capability gained via a smart jack is the ability to perform a loopback test, where the signal from the provider is transmitted back to the provider's location. Doing this allows the ISP to test the line from the central office without the need to have to test equipment or technician at the customer site. Of course, this loopback test will bring down the line, but then again, they wouldn't need to perform the test if you didn't call in a problem in the first place. So here's your CSU, Channel Service Unit, Data Service Unit. Here's the customer provision equipment at the customer's office, and here's the smart jack and the delocation point loopback, and here's the service provider. Demarcation point. Just so you're clear, a demarc is the precise spot where the service providers or local exchange carrier's responsibility ends and the CPE begins. It's generally a device in a telecommunications closet owned and installed by the telecommunications company telco. It's your responsibility to cable a task called extended demarc from this box to the CPE, which is usually a connection to a CSU, DSU, ISDN interface. Copper line drivers, repeaters. A copper line driver or repeater allows for a demarc extension length of up to 5,000 feet from the telephone company's demarc. These can be used to connect equipment across a campus, between floors of a high-rise office building, even between office buildings with underground cable connections. Local loop. A cable consisting of a pair of copper wires called the local loop connects the demarc to the closet switching office known as the central office CO. Central office, a phone company building that connects the customer's network to the provider's switching network. It's also good to note that a CO is sometimes referred to as a point of presence POP toll network. The toll network is a trunk line inside a WAN provider's network. This network is a collection of switches and facilities owned by the ISP. The public switch telephone network, as I mentioned a bit earlier, the portion of the PSTN that runs from your house to the rest of the world is known as plain old telephone service, POTS, and it's a popular method for connecting remote users to a local network due to simplicity, low cost and easy installation. Connecting to PSTN via ISDN, DSL, a cable modem, or even your cellular service is becoming increasingly popular. The two key concepts to keep in mind about PSTN are public and switched. Public basically means that for a fee anyone can lease the use of the network without being required to run any cabling. Switched explains how the phone system works, even though one or more wires are actually connected to your to your home and or office. All of them aren't always online or being used. Any dormant wires are still available to you in their offline state, so you can get online and join the network whenever you want. Think of it as like a standing reservation, and your phone number is used as an ID to access it. Because you initiate the connection by dialing a certain phone number, it's easy to imagine how technically impractical, if not impossible, it would be for this method to work if every phone number stayed connected all the time. If connections stayed active 24/7, the resulting backbone cabling requirements and problems would be insurmountable. Take for instance the US and the worldwide telephone systems. The actual numbering sequence varies in other countries, but the concept is identical. The phone company runs the local loop from the DMARC to the CO. All the pairs from the local loop cables within a small regional area come together to a central point, a lot like a patch panel in a LAN-based or unshielded twisted pair UTP network. This centralized point has a piece of equipment attached called a switch, which opens a communication session when it's initiated by a user who's dialed a phone number of the receiver and keeps it open until the conversation ends and the session is closed. On one side of the switch is the neighborhood wiring, and on the other side are lines that connect to either another switch or a local set of wiring. To make this concept really clear, picture the following scenario. When you want to make a call, you pick up the phone, which completes a circuit, and in most cases that gives you a dial tone. The tone is the switch's way of saying I'm ready. When you get that dial tone, it means that there's either a break in the equipment chain or the switch is too busy processing other requests. In many areas of the world, you hear a fast on and fast off tone, somewhat like a fast busy signal after giving a command string phone number to the local switch. This means that the other switches that the local switch is attempting to communicate with are too busy at that time. Recently, this tone thing had been replaced with a voice recording saying something like, "We're sorry, all circuits are busy, please try your call later." Sometimes you even get offered the shady sounding for only 99 cents. You can interrupt this call added to the message. This happens frequently on holidays or during natural disasters because the local area's phone company uses only the maximum number of wires, called trunk lines, required to handle the norms of usage capacity, plus a few auxiliary lines for peak usage. They keep equipment to a minimum because wiring and switches are really expensive. It's essentially a trade-off between providing 100% uptime and keeping the cost of leasing the connection from the phone company reasonably affordable. WAN connection types. With all that in mind, it's time to go over the various types of WAN connections you'll find on the market today. Figure 16.2 shows the different WAN connection types that can be used to connect your LANs together. WAN connection types: dedicated synchronous serial circuit switched, asynchronous serial ISDN, telephone company packet switched, synchronous serial service provider. Let's talk about the difference between WAN connection types you see pictured here. Dedicated leased lines. These are actually referred to as point-to-point or dedicated connections. A dedicated leased line is a pre-established WAN communications path that goes from the CPE through the DCE switch and then over to the CPE of the remote site. The CPE enables DTE networks to communicate at any time with no cumbersome set of procedures to muddle through before transmitting data. When you've got plenty of cache, this is the way to go because it uses synchronous serial lines up to 45 megabits per second. High level data link control HDLC and point to point protocol PPP encapsulations are frequently used on these lines. Circuit switching. When you hear the term circuit switching, think phone call. The big advantage is cost. You only pay for the time you actually use. No data can transfer before an end-to-end connection is established. Circuit switching uses dial-up modems or ISDN and is used for low bandwidth data transfers. I know what you're thinking, modems. Did he say modems? Aren't these only in museums now? After all that, with all the wireless technologies available, who uses modems these days? Believe it or not, some people still use ISDN. It's still viable, and there are many places on the earth where you definitely need a modem to get connected. Also, circuit switching can actually be used in some of the newer WAN technologies as well. Packet switching. This WAN switching method allows you to share bandwidth with other companies to save money. Packet switching can be thought of as using a network that's designed to look like a leased line, yet charges you more like circuit switching does, but less isn't always more. There's definitely a downside, and if you need to transfer data constantly, just forget about this option. Instead, get yourself a leased line. Packet switching will only work for you if your data transfers at the bursty type, not continuous. Frame relay and the super old X.25 are packet switching technologies with speeds that can range from 56 kilobytes per second up to T3 45 megabits per second. LANs use packet switching technology. The source and destination addresses in the packet header guide the network as it moves the packet closer and closer to the destination in the same way the post office takes an address letter and keeps it moving incrementally closer to its destination. This approach avoids the necessity of establishing an actual contiguous electrical circuit from one end of the other end electrical circuit from one end of the other. The method phone companies use to facilitate a phone call in their circuit switched networks. Most WAN connections work on the phone company's circuit switched network, whereby the point-to-point nature of most connections eliminates the need for addressing because there's only one possible destination between endpoints. But you still need a proper addressing scheme within your LAN to ensure that data packets reach their correct destinations. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.